Hey, Chem Kids. This is just a quick video here on how to use the PHET simulation for building an atom. So it probably take you to this part. Just hit the little arrow. And we can do any of these three things. So if we just go to atom, here is atom. And you can select some things here. So we can see what the net charge is. So positive versus negative. The mass number, okay, and we can change this from orbitals or clouds. It really doesn't make a difference right now. You're not learning anything about electrons quite yet. You can also show if it's stable or unstable, the nucleus, which we're really not doing anything with nuclear chemistry at this point in time. So if I add a proton to this element, it tells you it is hydrogen. So hydrogen has one proton. It's the only element with one proton, okay? If you notice, the mass is now 1. Protons have a mass of 1, what's called an AMU, or atomic mass unit. So and it is a positive ion. Okay, so ions are elements with a charge. Ions are elements with a charge. So in this case, hydrogen has a positive charge because it only has one positive thing in it. If I put an electron with it, now it's neutral. It's got one positive, one negative. Notice the mass did not change. Okay, so electrons that are traveling around the nucleus have virtually no mass. Okay, almost no mass at all. So electrons do not affect the mass number. If we put another neutron in there, or excuse me, put a neutron in there, now the mass number is 2. Because you have a proton that weighs 1 AMU and a neutron that weighs 1 AMU. Electrons don't weigh anything. Okay, it's still neutral because you have equal protons and neutrons. Sorry, equal protons, electrons. If I add another proton in there, it is now helium. Okay, the number of protons determines the element. Number of protons determines the element. Notice it is a positive ion because we have 2 positive charges, 2 protons, and 1 negative charge. So we have 1 more positive than we do negative. The mass is 3. 1 AMU for that proton, 1 AMU for that proton, 1 AMU for that neutron. So I want to add another neutron in there. This would be helium with a mass of 4, which is the most common isotope of helium. If we get out of that, if I can get down here, I just clicked on the bottom here where it says symbol. Same thing. I can go, I can pull in this proton. Let's put in some neutrons. And let's go with some electrons. So you can add things in. Notice 2 electrons fit in that first energy level, which again is not quite important yet. But this is lithium because it's got 3 protons. It's the only element with 3 protons. It's got 3 protons and 2 neutrons. So if we add those up, that is 5 AMUs. Remember, these things in the nucleus are the only thing with mass. And elements will not gain and lose these things. Without a nuclear reaction, which is almost not very often at least, these will not gain and lose those. Electrons are moving around. They can gain and lose those. So mass number here is 5. So when you see a symbol like this is the atomic mass or mass number. This is the atomic number that's being shown. This is the charge up here. So right now it is neutral because we have 3 positive protons, 3 negative electrons. If I add another electron in, it is now a negative ion. It's got a negative 1 charge because it's got 1 more electron than it does proton. If I added another electron, now it's a negative 2 charge because it's got 5 negatives, 5 electrons, and only 3 positives. And the last part that you can mess with is you can choose your game. So you can go to one of these, you can select something like this, find the element. So okay, we go 2 protons. The only element with 2 protons would be helium. And then it says, is it a neutral atom? Well, it's got 2 positives and 2 negatives. Remember, neutrons have no charge. So it is neutral. Yes. So you can do that game. If I go back to game down here, maybe let's start over. You can choose one of these other games like this one, 16 protons, 18 neutrons, 18 electrons. So this is telling you the mass, which would be the protons and neutrons added together, 34. Atomic number, which is the number of protons, this is the charge up here. So it's got 16 positives and 18 negative electrons. Neutrons have no charge. So it's got 2 more negatives than it has positives. So -2, check, go from there. So something you can mess with. Look at atomic structure a little bit on this website. Have a good day. It'd take me a while to figure out how to stop doing this.